Hello friends, in today's question, a thin circular ring of mass m and radius r is rotating about its axis with a constant angular velocity omega. Two objects, each of mass m, are attached gently to the opposite ends of the diameter of the ring. The wheel now rotates with the angular velocity. So it is given that we have a thin circular ring whose mass is given as capital M and the radius is small r, and it is rotating with a angular velocity of omega. And in the second part, on this thin circular ring, at the opposite end of the diameter, two objects, each of mass small m, are attached. So let us suppose this is one of the object and this is the other object. So, and the mass of each object is given as small m, and the ring is having the same mass, that is capital M. So the distance of each mass from the center of the axis is given will be r, and in this case we assume that it is now rotating with the velocity of omega prime. So let us call or say this first as an initial condition, and this we call as a final condition. And we know that the moment of inertia for the ring, let me write it here, moment of inertia of the ring is, let us suppose, is given as IR, and that will be equal to capital M and radius r square. And let us suppose the initial angular momentum according to initial condition. So you can say for initial condition, initial angular momentum let us denote it by L initial, and L initial will be given as m r square multiplied by the angular velocity. And now we come to the second part for the final condition. For final condition, now it is rotating with the angular velocity of omega. For final condition, angular velocity is equal to omega prime. Therefore, we can write that angular momentum of the ring will be equal to now m r square, and now it is m prime, and now we have two objects. Therefore, angular momentum of the two objects, angular momentum of two objects, this will be equal to 2m r square omega prime. Therefore, we can say that the final angular momentum let us that given as L final. Therefore, we can say that our L final will be equal to mr square omega prime plus 2m r square omega prime. Now we can use conservation of angular momentum. Conservation of angular momentum. L initial will be equal to L final. So we substitute the values. L initial is given as capital M R square omega, which will be equal to m r square omega prime plus 2m r square omega prime, and here r square is cancels throughout, so we can write this as m omega is equal to, we can take omega prime as common, so this will be m plus 2m. Therefore, we get omega prime will be equal to m upon m plus 2m multiplied by omega. So this is the angular velocity. This is the angular velocity. I think velocity was asked. Yes, angular velocity. This is the angular velocity of the ring with two objects placed on it along the diameter. Therefore, we can say our option number C is the correct option. So we can say option C is correct. So this completes the question. Thank you.